radical relationships have real-world applications. The formula d equals the square root of 3h divided by 2 models the distance d in miles that you can see to the horizon at a height of h feet. For a small pictorial expression of this, I'll draw my little person at the top of a really tall tower, and this horizon here, how far out can we see? This is ultimately what we're trying to do, right? Standing at the top of the tower, how far can we see to the horizon? So the D and the H is represented by the height in feet, and the D is the distance that you can see in miles. So if we apply this to our situation here, the height of the Sears Tower in Chicago, it's no longer called the Sears Tower. It's actually the Willis Tower in Chicago. It was called the Sears Tower for so long that people still call it the Sears Tower. Nonetheless, it doesn't affect our calculation because this tower is 1,450 feet tall. So if we plugged it into our function here, d equals the square root of 3h, h is 1450, divided by 2, we can use our calculator here. 3 times 1450 divided by 2, we get 2,175. If we take the square root of that, we get 46.63 miles. Now, the problem says to use our calculator and round to the nearest mile. So looking at 46.6, 46.6 is closer to 47 than it is to 46. So 47 miles we could see standing at the top of the Sears Tower, the Willis Tower in Chicago, provided that there's no fog so that we can see to the horizon. Another example, autism is a neurological disorder that impedes language and affects social and emotional development. New findings suggest that the condition is not a sudden calamity that strikes children at the age of 2 or 3. But a developmental problem linked to rapid brain growth during infancy. The graphs show that the heads of severely autistic children start out smaller than the average and then go through a period of explosive growth. They're growing very quickly. Understanding the cause of autism may be able to help us better help these children and adults who have it. The data for one group is modeled by y equals 2.9 times the square root of x plus 36. Y is the head circumference in centimeters at age x months, where months is between 0 and 14. According to the model, what is the head circumference at birth? At birth means that x is 0. So we would plug in 0 to our equation. 2.9 times the square root of 0. Square root of 0 is 0. 0 times 2.9 is 0. 0 plus 36 is 36 centimeters. So at birth, the head circumference is 36. According to the model, the head circumference at 9 months, we would plug in 9. 2.9 square root 9 plus 36. We get 2.9. Square root of 9 is 3. Let's pull out our calculator. We get 44.7 centimeters. The head circumference at 14 months, we'll have to use our calculator on this one. Square root of 14 goes in. So let's do that first. Square root of 14 times 2.9 plus 36. And we get 46.85, 46.9 approximately. Now, the last bullet, according to your results, determine if the given model describes healthy children or those on the severe autistic spectrum. So we're going to look at these values in our graph up here and see if we can determine which of the two graphs match up to our values. So I will use a bright yellow here. X is 0. I'm going to write my ordered pairs first. 0, 36, 9 and 44.7, and 14 and 46.9. Okay. So these three ordered pairs are the same values that we just calculated. I'll take my yellow, 0, 36, 9, 44.7 would be here, and 14 and 46.9. So 50, looks like 50's up here. 46.9, 47, looks like it's there. So these 3 points look like they're lying on the blue graph for the healthy children. So it would be a good indicator that this model is that for healthy children.